As promised, this is the circuit for that garden lighting timer that I showed off. It's a very simple circuit. There is no microcontroller and certainly no Arduino in here. It has two chips, the LM393 dual comparator and the 555 timer. The purpose of this circuit is fairly simple. It's got an output which, when pulled low, will turn the lights on. It needs to do so for a set time whenever one of the sensors is closed. There's also a requirement that if the sensor is kept closed, the light must still turn off after the time has elapsed. That's because these are sensors for the back gate and the back door, and we tend to leave the back door open until after dark in the summer to let the pets go in and out. Right, you've got your basic 7805 reg, we all know that bit up there. The LM393 is a comparator chip. It's sort of like an op-amp. It looks like one in symbol, it works a lot like one, but the output is not the same as an op-amp. The LM393 has an open collector output, so it's easier to interface to certain digital circuits like I'm doing here. We've got the old-fashioned CDS cell, not a photo transistor, this is actually a CDS cell, don't see those much anymore, with a 1K resistor there. Note the 6.8K when I was testing it indoors, had to put that down when I went outside into brighter sunlight. And a old potentiometer from a TV tuner circuit as your threshold adjust, so everyone should know how this bit works. This unconventional looking design here lets the 393 drive both the status LED and the input to a BS170 FET, which acts as an AND gate, and that makes it a lot easier to adjust than the conventional security lighting, where you've just got to twiddle the knob and hope for the best. In this case, all you need to do is go out at the right time of day and turn the adjuster until the light changes state, and you've then set it for that level of ambient light. Simple, does the job. Verified that the voltages here are suitable for feeding the BS170, and they are exactly as I would like to see them. The 555 is acting as a timer chip, basic A-stable. In order to get a delay of a few minutes out of this, I've had to use a fairly large capacitor here and a really large resistor here. This is the only time I have needed a 1 mega ohm variable resistor. This actually came out of an old relaxation oscillator. It used to be used in education until it was deemed too dangerous for the little kiddies to be in the same room as a 90 volt supply. So that went, I got it, came in useful. I've slightly violated the 555 specifications here. It's supposed to have a 10 nanofarad. I didn't have a 10 nano, so I put a 20 in. That seems to work just as well. And this 3K resistor here is implicitly an OR gate. The output from the 555 is not open collector. It is driven each way, so if you tried to ground it, it would burn the chip out. But by putting a 77 or 100K pull-up in the relay box and that 3K there, all I need to do is pull the intervening line to ground, and I've got a convenient party mode override that forces lights to stay on. This circuit is made entirely from scavenged or cheap as dirt components, and it does much the same as any other security light circuit. The only difference being the ease of setting light and that it can be interfaced to whatever sensors I require. Once I get said sensors in, I should have a garden lighting system that is fully automatic. Anytime someone goes outside, lights come on, and a lot more reliable than your standard PIR security light, because we've got those and it is so fiddly getting them set up just right. They're always either so sensitive the pets will set them off, or so insensitive you don't set them off, or there's that sweet spot in the middle where both conditions are true. So I've shown that you do not need to use Arduinos even today. The old school still works. The laws of physics have not changed.